Hello wonderful person, this is Anton and let's talk about wormholes. And to start, let's go back to 1935, or the year when this idea was officially proposed. And that's because in 1935, Albert Einstein published two major distinct contributions to a paradox sometimes referred to as Einstein-Podolsky-Rosen paradox. The idea that tried to challenge the completeness of quantum mechanics, with a second paper describing something known as the Einstein-Rosen bridge that explained a new model for general relativity, eventually creating the principle we call wormholes. And the point for both of these papers was to address fundamental questions about our reality and the structure of the universe. But after decades and decades of research, or I guess more importantly after decades and decades of science fiction shows, today we generally imagine these wormholes as something like this. Something that you use to travel in space from one galaxy to another, very often in the blink of an eye. However, when it comes to real science, despite decades and decades of research and lots of observations, even our best telescopes so far have found absolutely nothing. Not a single wormhole anywhere, even though lots and lots of black holes were discovered and confirmed over the years. And well, one mystery here is of course, why? Why so many black holes, yet no wormholes? And that's kind of one of the main reasons for this new study by Enrique Castañaga, Sravan Kumar, and Joao Marto. Because here the main conclusion is that we haven't found wormholes because there are no actual tunnels in the universe to travel through space. And instead they represent something entirely different that we just basically kind of misunderstood because Einsteinian principles are sometimes a little bit challenging. And so they present wormholes not as a tunnel, but as a connection between two opposite arrows of time, or a kind of a time mirror. And so let's talk about all of this in a bit more detail because this is actually kind of interesting, and because it also connects to some other propositions by a lot of other physicists. But to understand everything, we do have to discuss Einsteinian's and Rosen's propositions and what they were trying to achieve. Because in this case, neither Albert Einstein nor Nathan Rosen were actually trying to build a Stargate. They were trying to solve a different problem referred to as the particle problem. Specifically the particle problem in the general relativity. That's actually the name of their study as well. You can read their study and the entire discussion in the description below. And so they wanted to physically describe tiny subatomic particles like, for example, electrons, as purely geometric structures inside the fabric of space that forms the main principle in the general relativity. And specifically they wanted to avoid any pitfalls when it comes to singularities or infinity, because that usually breaks the math and makes things very difficult to explain. So here they were trying to avoid something like infinite gravity, something that we usually use to describe black holes. And to do this, they proposed a kind of a bridge that connects two different points in space-time, where space meets itself. This image right here sort of represents this pretty well. And effectively this is a mathematical link between two symmetrical copies of space-time that in some sense I guess also resembles some kind of a hole, a wormhole. But once again, that's not what Einstein or Rosen proposed. They were not suggesting these were any kind of tunnels, and they were not suggesting this is what spaceships are going to be using in Star Trek to travel. And that's because for both Einstein and Rosen there was one main particular idea. Their argument was against quantum mechanics. They believed quantum mechanics was incomplete because it predicted this spooky action at a distance that we refer to as entanglement, and Einstein believed that it violated local realism. And just to give you a bit of a spoiler, in the last couple of decades, unfortunately Einstein has been proven incorrect. So yeah, quantum entanglement and spooky action at a distance seems to be real. But nevertheless, this 1935 publication was pivotal in continuously challenging quantum mechanics. Here this was using thought experiments and different types of correspondence, one of which we recently discussed in one of the videos in the description. But it wasn't until later, in the 1950s and in the 1960s, that we finally had new equations that tried to connect all of this to a physical bridge that could open and might resemble some kind of a shortcut through space. Although there was always this one problem. In general relativity, these would be super unstable. As a matter of fact, they would pinch off or collapse even if a single beam of light tried to pass through them. And so in order to keep them open, you would need some kind of an exotic matter or some kind of a negative mass that unfortunately, according to modern physics, potentially does not exist. And so because of this, many physicists eventually concluded that the idea behind these wormholes, and here we're talking about these types of wormholes, might be nothing more than a mathematical curiosity and since we haven't found them in the real world, they just don't exist. With other physicists eventually concluding that maybe the entanglement itself, that spooky action at a distance, is actually a wormhole and just needs to be mathematically described through general relativity that has not been done yet. Either way, the conclusion was that wormholes are a cool science fiction story, but potentially do not exist. But this new study presents a new argument and actually a completely different explanation. The argument here is that it's not that they don't exist, but the reason we cannot find these spatial tunnels is because we actually misunderstood the original explanation. Or to be more exact, if we try to read through Einstein and Rosen explanation once again, it becomes pretty clear that he never specifically mentioned space. And in space-time you can also have time. And so these could be actually mirrors in time. And since in physics the fundamental laws don't really care about the flow of time, as in they don't care which direction it's flowing, and basically if you reverse the time in the equations the laws still work, here the researchers behind the study suggest that this wormhole equation is not meant to be a tunnel to a distant star, but is actually a connection between two sheets of space-time that have completely opposite arrows of time and basically run in opposite directions. So once again, a mirror in time. And so on our side of the universe, time flows forward and in one direction, but on the other side, it flows backwards relative to us, but will appear normal to anyone on that other side. And in some sense, this is directly based on the framework referred to as direct sum quantum field theory, which essentially treats the universe as a pair of states joined by a mathematical bridge. So in other words, in terms of mathematics and various ideas, there is really no violation here. In terms of numbers, it kind of makes sense. And more importantly, it makes sense if you consider those explanations from 1935. Now obviously this is not something we're going to be able to prove anytime soon, but assuming this is correct, just for 1 second, this in theory changes our understanding of the universe entirely. Because for example, instead of the Big Bang being a single point where everything began, instead it might be actually kind of a throat or a massive Einstein-Rosen bridge, a massive wormhole, that starts two opposite time frames going in opposite directions. This is also sometimes referred to as the Janus point, named after the famous Roman god with two faces. And so at this point, the arrow of time splits in two opposite directions, and space expands forward in time for us, and expands backwards in time for a mirror universe. And so yeah, this is a proposition that suggests two mirror universes running in completely opposite directions. And if this sounds a little bit complicated and possibly a little bit far-fetched, the thing is, this is definitely not the first time this has been proposed, and not the first time something was explained in a very similar way. And actually one of the more important explanations is this. The 2018 study by Latham Boyle, Neil Turok, and Kieran Finn that literally tries to explain everything in the universe through a model referred to as CPT symmetry. And this is actually a super fascinating idea that Neil Turok explains in a lot of his videos on YouTube, but in essence, here they also suggest the same principle, with the universe starting at the Big Bang and running in opposite directions. So we have the universe and the anti-universe. And the reason they think it makes a lot of sense is because here it actually explains many different mysteries, including dark matter mysteries, in a very elegant way through a specific type of a heavy neutrino that naturally appears inside this symmetric vacuum. Now this has not been discovered or confirmed yet, but mathematically their idea is actually quite brilliant, and quite a few physicists have been intrigued by this for quite some time. And very similar ideas have been proposed by other physicists, including Julian Barber and Paul Singleton. Basically they all propose a kind of a mirror-balanced universe, with some models proposing that black holes seem to act as rebalancing mechanisms, ensuring the total energy of the system remains zero. But just to simplify all of these points, here it redefines our initial assumption that this was all about traveling through space, and instead presents us as a kind of a travel through time, or technically, a very specific point that links two different time frames, one going forward and one going backward. Okay, well, you might still be wondering, cool, Anton, but what's with all the philosophy and why does this matter? And more importantly, is there actually any physical evidence? Or at least that's what I was asking myself after reading this. And surprisingly, there might be some evidence. And once again, this evidence seems to come from the famous cosmic microwave background. And here for over 20 years, cosmologists have been kind of puzzled by the bizarre anomaly, or the bizarre asymmetry, that seems to be persistent and seems to be very large. Basically here, if you look at the CMB, one side of the sky appears a little bit different from the other side, in a way that standard models cannot really explain. As a matter of fact, according to their study, their model seems to be 650 times more likely to be correct compared to the standard model. In other words, even though the original theory predicts that the temperature of the early universe should be fluctuating asymmetrically without any pattern, because of this temporal effect and because the universe potentially started in two directions, this possibly formed this somewhat bizarre asymmetry. And so since this model predicts that space-time is connected and creates a specific geometric pattern, this might explain the anomaly. And of course suggesting that these wormholes are not some kind of a science fiction portal, but basically a fundamental part of the universe that seem to show signs in the oldest light out there, in the cosmic microwave background. Although just as a side note, we've actually discussed this idea of asymmetry in the CMB in some of the previous videos in the description, and right now there is no exact conclusion yet. The actual asymmetry is definitely there, and this unusual lopsidedness of the universe has been confirmed, but we just don't really know what's causing it. But at the same time, if this idea is correct, it might also solve another problem, the famous black hole information paradox. And this is something that was proposed by Stephen Hawking in the 70s, when he basically showed that black holes can eventually evaporate, but if they do evaporate, it suggests that any information that fell into them would eventually be destroyed. And that's something that should not be happening in the universe, violating a lot of models. Basically, in physics, we assume that information should always be somewhere and it should not just disappear. However, if the Einstein-Rosen bridge is just a connection of two eras of time representing a time mirror, the information does not disappear, it simply continues its evolution along the mirror in the opposite direction. And so the event horizon in a black hole is not a dead end, instead it's just a transition point where the arrow of time flips. And that means that these wormholes represent a kind of a fundamental balancer in nature. Once again, these are not shortcuts for spaceships, they're just a kind of a geometric glue that keeps the universe consistent and unitary. And so for every type of forward motion in time, you will have a counterpart going backwards. And so as the researchers behind the study put it, this does not contradict Einsteinian principles and instead actually completes them. It completes Einstein's relativity with all of the recent observations by basically suggesting that time seems to flow in two directions instead of just one. And although this means that we'll never use wormholes to visit other galaxies, it also means that maybe, just maybe, there might be a way to visit the other universe. I mean, none of this is proposed in the study, but that's kind of the implication. Anyway, this is a pretty complex topic, and obviously there's just no physical evidence for any of this yet, but if one day certain neutrinos are discovered, at least some of these ideas will be proven correct. And so until then, thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM it directly, or by joining the channel membership that grants you early access. You can also support the channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.